Hi there, through this video we will learn how to graph linear functions using the form y equals mx plus b. And before we proceed to the examples, the reason why this one is helpful in order for us to graph a linear function is because this already gives us two important information, and those are the slope and our y-intercept. Okay, so whatever the value of your b is, that gives us the point 0, b. Okay, and we will apply that later in our examples. So for our example, we have y plus 2x equals 3, but this one is not yet written in the form y equals mx plus b, which means y must be left on the left side and the rest must be placed on the other side. So we need to remove the 2x here by adding negative 2x on both sides, so we can cancel this, and we'll just have y is equal to negative 2x plus 3 because it's positive 3. Okay, and this gives us the value of our slope, which is negative 2, and it is preferably written in fraction, which is negative 2 over 1. So negative 2 is also the same as negative 2 over 1. And why do we need to write it in this way? So we can clearly see the number of units for the rise over the run. On the other hand, our b value is 3, which gives us an idea about 1 point, or 1 point in our graph, which is the y-intercept, and that is 0, 3. And this will be our starting point, 0, 3. Here it is in our Cartesian plane. And then from 0, 3, we will be using the slope in order to find the other points. And the slope is negative 2 over 1. So it's negative 2, so instead of rising 2 units, or moving 2 units up, we will move 2 units down. So 1, 2. And then 1 unit for the run, so we run it to the right. 1 unit to the right. Okay, so here's our second point. Now, in graphing linear functions, you may just have 2 points to graph our line. But if you want to continue, you may do so by using the same slope. Move 2 units down and then 2 units down. Here it is. Okay. 2 units down and then 1 unit to the right. So here's our second point. And if you want to still continue, 2 units down and then 1 unit to the right, and so on and so forth. But again, 2 points are enough to graph our line. So this will be the final graph of our linear equation. There you go. As easy as that. Again, all you need to know is the slope and our y-intercept. For our second example, we have y plus 5 equals to x. Again, we need to set aside the y in the left side and the rest on the other side. So we need to remove the 5 here by adding negative 5 on both sides. So we can cancel this and we will be left with y. Y equals 2x minus 5 or plus negative 5, which tells us that our slope is 2, or that is also 2 over 1, which means 2 is our rise and 1 represents the number of units to run. And then b is negative 5, which gives us the y-intercept, which is 0, negative 5. Now let's plot the y-intercept first, and here's our y-intercept. And using our slope, which is 2 over 1, it will rise, or it will move 2 units up, 1, 2, and then 1 unit to the right, since both are positive. But if it's negative, then it's either we move down or we move left. Okay, so the second point must be right here. There you go. This is already the graph of our line. For our last example, we have negative 3 plus y equals 3x. And again, we need to rewrite it in the form y equals mx plus b, so we can find out our slope and our y-intercept. And to do that, we need to remove the negative 3 here by adding positive 3 on both sides. So plus 3. This will be cancelled, and y will be equal to 3x plus 3. And from this, we can get two information. The slope is 3, or that's 3 over 1. And the y-intercept is at 3, or the point is exactly at 0, positive 3. Now let's plot it in our Cartesian plane. So from this point, 0, 3, we'll move 3 units upward, 1, 2, 3. And after moving up, we will run 1 unit to the right since both are positive. So from 6, move to the right. So there you go. This will be the graph of our line. Alright, so that will be all for our examples. And on the next video, I'm going to show you another way on how to graph linear functions.